Let's do one last one. Feel free to pause the video and see if you can find it for yourself. This one I actually gave you the function, so you could check it over algebraically to see if you get the right answer, and that's what we're going to do on this one. The last one, I didn't tell you the name of the function, so we couldn't check it over with our work, but we will with this one, and I think it's nice. I like having an equation because I think these pictures are difficult. So let's do it without the equation at first. Let's just look at a picture and figure out, do we think it's a U or an upside down U? So up on the top here, because we don't have too much space, I'm going to write concave up, concave down, and draw myself as my U again. Full U, left side of the U, right side of the U, concave down, upside down U, just the left side, just the right side. So my first piece of the graph, I want to see what it looks like. This piece here, does that look like it's part of a U or an upside down U? This one looks pretty perfect to me to almost just be like a full U right there. So I'm going to call that piece concave up. All right. And then I have this little piece here that when I trace it and I try to figure out what part of the U it belongs to, I think it looks like the left side of concave down. So I think I have a tiny piece that looks concave down. It's so small though, I'm not really sure. I might refer to the equation, which is totally fine. But I think it flips down for a second. And then after that, this piece here, I would argue this looks kind of like the third way of concave up. Looks like the right side of a U that's oriented upward. So I feel pretty confident with that last piece that it's back to concave up again. So the only thing I'm kind of unsure about is this is so tiny, but I'm pretty sure it looks like this part of concave down, the second way. So let's see what we think here. So we found our concavity, and let's just guess some inflection points, and then we'll find them for sure with the equation. So if I switch from concave up to concave down in this region here, I need to try to find an inflection point that's in between. So maybe I will go with this piece right here, somewhere between -2 and -1, so maybe -1.5, comma, what do you think the y value is there? It looks like it's down at like -1 point something, so maybe -1.1. I'm going to put a question mark on that. I'm not so sure if that's right where it is, but we'll go in with the equation and figure it out. And then this one, I switch from down to up, and I'm just going to say 0, 0. I'm going to guess a whole number, and it might work, it might not. We're going to see the exact answer by referring to the equation on this one. So I'm trying to label my inflection points in there. So I'm going to call them POI, point of inflection. Well, before we write our conclusions, let's do our 2 steps to this and see if we can find what the answers are for sure. So my first step is to take the second derivative and set it equal to 0. So my first derivative, I'm going to bring down the power. Half of 4 is going to be 2x to the third, plus the derivative of x cubed is 3x squared. And thankfully, I don't have to work with the first derivative, so I'm not going to worry about factoring that or anything crazy. I'm going to move on to the second derivative. The second derivative is 6x squared plus 6x. And I'm going to set the second derivative equal to 0, a lot easier to work with than the first derivative in this case. I'm going to factor out a GCF because it has an x squared I have to factor. So it's going to be 6x times x plus 1. So 6x would be 0 if x was 0, and x plus 1 would be 0 if x was -1. So these are my possible points of inflection. They are not points of inflection unless concavity changes there as well. So is this piece really a little bit of concave down? We're about to find out. So we'll put it on our sign chart. -1 and 0. They're special. They make the second derivative 0. So I'm going to label them. They might be inflection points if concavity also changes there. I'm going to switch out my colors here and do some random test values. So I'm going to test -5 maybe, just to be a little bit different. Plugging into the second derivative to find concavity. 6 times -5 is negative. -5 plus 1 is negative. Two negatives make a positive. Positive second derivative means concave up. Careful, we're not increasing and decreasing anymore. My second piece, I can choose anything between -1 and 0. I'm going to go with -0.1. So 6 times -0.1 is going to be a negative, and -0.1 plus 1 is going to be positive. Negative times a positive makes a negative. Negative second derivative means concave down. Last interval, I could plug in anything I want to. Maybe I'll just be boring and plug in 1 instead of something super far away. 6 times 1 is positive. 1 plus 1 is positive. I have a positive second derivative, which is concave up. So I really did switch in here. It really was concave up to concave down to concave up. Exactly what we guessed by looking at the picture, but I personally like the equation because then I know for sure instead of having to kind of go with my gut on the picture. Were we right with our inflection points? Well, concavity changes, so they are points of inflection. And we were close. We got 0, 0, right? That is 1. And this one, we thought it was -1.5. It's not quite there. It's at -1. That's where our inflection point is. So I'm just going to move that dot away. The real inflection point is at -1, which we were close enough on the picture that I would give you definitely full credit because it is hard to tell, and I understand that. But the actual answer we could get from plugging into the equation since we were given it this time. So our final answers for this are that we have inflection points at 0, 0, comma, -1. I could try to estimate this y value by looking at the graph, or I could plug into the equation. 1/2 times -1 to the 4th is just going to be 1/2, plus -1 cubed is going to be -1. So I have 1/2 minus 1, which is -0.5, or -1/2. Which maybe you could tell by looking at the graph that it was -1/2, but you could also just plug into the original equation, will give you the y value of an inflection point. Lastly, for concave up and concave down, I need to interpret either my sign chart or the graph. Concave up is happening before -1 and after 0. So I'm going to say -infinity to -1, union 0 to infinity, which you probably could have gotten that part from the graph if you wanted to. And then concave down is -1 to 0. So there's a few examples of looking at it graphically. We're going to do some more algebraically just from an equation so that there's not as much pressure as looking at a picture. And our next section is curve sketching, and that'll make reading these pictures easier in the future too.